Okay, welcome to the second part of this Python course. So in this part, we're going to start using some of the ideas that we've learned in the Python programming tutorials so far to start developing computer code that can solve plate tectonic problems. So specifically, we're going to try to come up with some Python code that can, if we give this code 2 points on the globe in terms of their latitude and longitude, if we give this code these 2 points, then the function will calculate the distance between these 2 points. Okay, so the angular distance as if you were driving there across land or something. Okay, so what I would suggest is that if you haven't fully understood everything in the previous videos, my suggestion would be to take a little bit of time to have a look over those one more time and just get a little bit more comfortable with using things like creating functions and if else statements and loops as well. But if you're comfortable with that, if you feel like you're ready to start, then this is the next step. Okay. All right. So in the previous video, we created a function called convert to northing, and so this function took a latitude and a direction, and just checked if it was already a northing or not. And if it was, it left it alone. If it wasn't, it converted it into a northing. And so I asked you to go away and try to write your own function to convert a longitude into an easting. Okay, so hopefully you've done that. So I've gone away and I've done that myself. So here is the convert to northing function we created previously in the previous video. And I've just written a really simple convert to easting function here. Perhaps we should have a really quick look at that. So we've defined our function convert to easting. We're inputting to that function a longitude and a direction. So in this case, the direction should be either west or east. So now looking at the actual logic inside this convert to easting function, if the longitude that you give me is exactly equal to 0, then we return that longitude, which will be 0, and we return the direction as being east. Else, if the longitude is not equal to 0, we check this one. If the direction that you give me is exactly equal to w, so west, the string w, then we create a new longitude as being 360 minus the longitude that you've inputted into the file, and we change the direction to the easting, and we return this new longitude and the new direction east. Else, if the direction, so basically this else here is saying if the direction is equal to east, because if it's not equal to west, it should be equal to east, then we just simply return the longitude you've given me and the direction you've given me, which of course is east. So there's not actually that much error checking in this case. So for example, someone could put in give you a longitude of greater than 360. So you may like to take this really standard version of convert to easting and add in a little bit of error checking if you would really like to improve this function. But as long as we use realistic or real values of longitude, this function will work for the demonstration purposes. Okay, great. So what we want to do is we want to provide our function with 2 points, right? So I'm just going to get rid of this text down here. So remember, the first thing we do in a file is we put anything we want to import. We define our function. So in this case, we've got 2 functions. And then after we've defined our functions, that's when we can start typing the text of the rest of our file. So what I'm going to do is I'm going to define 2 points A and B. So I'm going to say A lat is equal to 40. So the latitude of A is equal to 40. A long is equal to 70. So the longitude of point A is equal to 70. We of course need directions for the latitude and longitude. So I'm going to say A lat dir I'm going to say that's already a northing. A long dir, so my direction of my longitude, I'm going to say that's actually, I don't know, do you say westing? Anyway, it's in the westerly direction. So we're going to have to convert that to an easting, right? Similarly, I'm going to create a new point on the globe, point B, and the latitude of B is going to be 61. The longitude of B is going to be 150. The B latitude direction, I'm going to say again, I'm going to again say it's already a northing. And B long direction, I'm going to say again it's a westerly, in the westerly half of the globe. So now I have my two functions, my 2 points, A and B, okay, with their latitude, longitude, and northerly and westerly. Okay, so the first thing I'm going to want to do is convert these points A and B to northings and eastings, okay? So I can use these functions that I've defined above to do that. So let's do point A first. So I'm going to say A lat 2, so, or let's say A lat nu. Okay, so remember this northing, convert to northing function returns a latitude and a direction. Well, let's just think about this for a second. The direction, because we're returning a northing, the direction is always going to be n, right? Always going to be a northing. So I'm actually just going to ignore that second part because I don't actually need it at this very second. So what I'm going to do, I'm going to return a new latitude, and then I'm just going to have this underscore here in the second output, which is the direction, because I don't actually need it. Okay, well, I'm going to write equals, this is a convert to northing. And I have to, if you recall, to convert to a northing, I have to give it a latitude and a direction. And so for point A lat is latitude, and A lat dir is the direction. Okay, so this part of the code here should convert my point A latitude into a northing. Okay, I need to do the same thing for the easting, so I'm going to convert to easting here. Of course, I want to input a long nu. Oh, sorry. Sorry. I want to create a new longitude potentially, which I'm going to call a long nu. I'm going to convert to easting, and my input is going to be a long, which is this point here. My direction is also going to be a long dir. Okay, so this function will take my the value of a long that I've defined here, the value of the direction of a long, so string W for westerly, inputs into my convert to easting, and I should get back out of that a new longitude, and I already know the direction is going to be in easting. Right? I need to do this for point B as well, so let's just change all those A's to B's. And then we essentially have converted our point A and our point B to northings and eastings. Okay, so we've got these A lat nu, A long nu, B lat nu, B long nu are our new points, which are northings and eastings now. Okay, so to find the distance between these 2 points, we have a few steps that we have to take. Okay, so the first thing is we have to convert these 2 points from polar coordinates, which is what we're in now, angular coordinates, right? Latitude and longitude are given in terms of angles. And we need to convert these to Cartesian coordinates, or in other words, X, Y, Z coordinates, okay? So if you take a look at the workbook that we're working through, if you go to page 17, I'll zoom in a little bit. What we're going to do is we're going to call this thing lambda A to be the northing of point A, i.e. the latitude. So we just calculated A lat nu. This is the northing of point A. Okay? So we're going to call lambda A the northing of point A. Phi of A is going to be the easting of point A, i.e. the longitude. So we've also just calculated the longitude of point A. And similarly, we calculated the latitude and the longitude of point B as well. So the polar Cartesian transformation, to convert these angles that I have to Cartesian points, i.e. an XYZ coordinate system, we perform the coordinate transformation, okay? So we have three components for point A. We have the X component, the Y component, and the Z component. And the way we calculate these X, Y, and Z component are through these three equations here. We have to take the cosine of the latitude and multiply that by the cosine of the longitude. And that gives us the X component of A. The Y component, we have to take the cosine of the latitude and multiply that by the sine of the longitude. And for the Z component, we just simply take the sine of the latitude. Okay, so we're going to do that now. We'll come back to our Spider software. So we've converted to northings and eastings. So let's now convert to Cartesian coordinates. So I'm going to have three components in my Cartesian coordinate system for each point. So I've got AX, AY, and AZ. I'm going to have also BX, BY, and BZ. And so recall AX, the X component of A, is cosine of latitude times cosine of longitude. So I'm going to write numpy dot cosine of A lat nu times numpy dot cosine of A long nu. Okay, so cosine of latitude times cosine of longitude. Just check that. Cosine of latitude times cosine of longitude. Similarly, AY is going to be cosine of latitude times sine of longitude. So it's going to be very similar to the previous line. I'll copy that and paste it through, except now instead of cosine, the second one is sine. Okay. And so thirdly, the Z component is going to be sine of lambda A. So lambda A being the latitude. So we're going to take here numpy dot sine of A lat nu. Okay, we can do the same thing for the B's, right? Now, can anyone spot the problem so far while I'm copying and pasting all this? So there's obviously a problem here that we have to deal with before this is actually accurate. Okay, so in case you haven't seen the problem, our latitudes and our longitudes are in degrees. You know, latitude, if you recall, goes between -90 and 90 degrees. Longitude is going to go between -180 to 180. But these trigonometric functions in Python, these are going to be, they need to be in radians, actually. So before I can actually do this step here, I have to convert these angles, A lat, A long, B lat, B long, I have to convert these angles into radians. So actually, what I'm going to do is I'm going to define these two angles, lambda A and phi of A. Okay, I'm going to define those in radians. So let's say lambda A. So lambda A is equal to the latitude, right? So the latitude, but in radians. So we're going to go numpy dig to radians A lat nu. So now, here I've used the Python version, numpy dig to rad. If you wanted to, you could use the version the function that you made yourself a few classes ago to convert from degrees to radians. It's up to you. Okay, phi a is equal to numpy degrees to radians of the longitude, so a long nu. Okay, I'm going to do the same thing for b, so lambda b and phi b, so I'm just going to change these a's to b's. Okay, good. So now, I've written this in the wrong place, sorry. So I'm going to copy and paste this down here. Okay. So I have my definitions up here, my functions. I take my latitude and my longitude with their directions and convert to northings and eastings. Then I convert these new northings and eastings to lambdas and phis. So where lambda is the latitude in radians, phi is the longitude in radians. And so now I'm ready to actually convert these to Cartesian coordinates. So this should actually be lambda A, lambda A, and this should actually be phi A. And let's just double check. We've got 3 lambdas there and then 2 phis, so let's just make sure it's consistent. 1, 2, 3 lambdas and then 2 phis. Always good to check your working. Let's now copy and paste this for our b values, changing all our a's to b's. Okay, and now we actually should have the x, y, and z components for both of these points, right? So you might like to run this to check that there's no errors, and I don't get any errors. So in the next class, we're going to calculate, now that we have the points in Cartesian coordinates, x, y, z space, in the next video, we'll calculate the distance between these 2 points.